So far, we've been dealing with individual pieces of data, right? I have somebody. I have their name, I have their age, I have their student ID. Or we've been dealing with lists of the same. But with an object, you can cluster that data together. You can say, I have a student, and oh, by the way, he has a name, and he has, an age, and he has a student ID. It's one piece of data that you can shuttle around. You could write it to a disk, a file, you could pass it to a function or whatever, just as one piece, just like with a list, right? You have a whole pieces of data, but they're all the same kind of thing, right? A list is a series of scores, or a list is a series of strings, right? Names or whatever. It's all similar, right? But an object can be composed of completely different pieces of information. And if you think of our turtle class, not our turtle class, we didn't invent it, right? It's got all sorts of pieces of information embedded in it. It's got an X and a Y coordinate. It's got an angle that it's going at. It's got a color of the pin. It's got a thickness of the pin. It's got a speed. It's got whether the pin is up or down. And although we didn't play with it, the pin can be different shapes. The pin can look like a turtle, or it can look like a cursor, or the pin can be hidden. Stuff like that. So the pin, each turtle has to keep track of all of this. Now, if you were going to only have one turtle on the screen, these could just all be variables, right? Just like we have been doing. In my code, I could declare an X coordinate and a Y coordinate and an angle and a color, and I could move that turtle around. And that'd be great for drawing a picture with one turtle. But the turtle library lets you have multiple turtles on the screen at the same time, like this. Probably wind up commenting this out in a minute, so you don't necessarily have to type it. It's just going to be a demonstration that you can create two turtles and have them do two different things. So T1 is equal to, that's actually lowercase there, turtle.turtle, parentheses in parentheses. This is important. That's how you create an object. It looks like a function call, and it really is. It's calling what's known as the init function of the class, except Python calls it the underscore init function. Well, but let's make another turtle. Same business. Reason for the parentheses is it calls the init function, and the init function, which is called the constructor in other object-oriented languages like Java, you can pass information into it. You can say, I want this information, I want the object to be pre-filled with this information. Now, I don't know what kind of information we can pass into the turtle, so I'm going to skip that for now. So I'm going to set the angle of one turtle going one way, the angle of the other turtle going the other way, so one's going to be kind of going up, straight up, one's going to be kind of going to the southeast, towards Florida. We can set the speed of one to draw real quickly. T1.speed, like 10, he's going to go fast. T2.speed, he's going to go real slow. And T1.forward, FD, he's going to go 200. And T2.FD, he's going to go 300. Real slow. Well, since he's drawing slow, I'm going to lower his distance that he's drawing. And when we run it, and we could change the color of each one. Let's see if we got the syntax for that in my head. I'm just going to say T1.color right here. I may not have the syntax right, in which case I'll just comment it out. All right, so you can see that each object is holding information, right? Each information has a color, an angle that it's going, each object has a color, an angle that it's going, a speed that it's going, and an X and a Y coordinate that it's currently at, so that when it starts drawing, it knows where to start drawing at. We could create 20 turtles and have them all moving around on the screen. That'd be impossible to do with the procedural programming we've been talking about unless we kind of kludged it, hacked it together using lists, right? You could have a list of colors and a list of angles, but it's far easier if we can cluster all this information into one object so that we can pass that object around. We can make a function that did all this, or to make it draw a flower or whatever, and then we could pass the other turtle into the same function and it would draw a flower. You know, maybe with different colors and stuff like that. And yeah, it's not angle. Wouldn't mind if it was, and maybe they have that option, but it's not. That's not the syntax. Okay, so I'm going to turn the one that I wanted to go 90 degrees left, so fix that. And the one that I wanted to go downward right, I'm going to set him to go right 45 degrees. Or you can do left negative 45, right, and it would have the same effect. So fix those two lines. Alright, so right, you could have them all do different things, draw circles or whatever, and all we have to do is reference that object, right, to get it to do that. I feel like making him draw a spiral. I could write a function and I could pass one of the turtles to it, he would draw the spiral, and later on if I wanted to pass a second turtle to it, he'd draw a spiral in a different place. So the turtle is an object based on the turtle class. And we're going to define our own class. Maybe I need to keep this up if some people are behind, but the stuff that we're doing next is actually more important than the turtle. The turtle was just to demonstrate the concept that each one has different pieces, different clusters of information, and they're not all the same type, right? Our lists were all of the same type, a series of integers or a series of strings or whatever. So the difference between an object and a list is that while both of them can hold groups of information, the list will be a group of elements or a series of elements of all the same type and meaning. I'm going to change that word group to series. An object is a group of data of different types, possibly different types. Maybe it can all hold, all the same type. If you're clustering a person together and you're tracking his first name, his middle name, and his last name, it's all going to be strings, but it's data of different types. Oh gosh. Representing one complete entity. That's all sort of fancy talk, but I hope you get the idea. And that's the way things are in the real world, right? I'm a person, I have a name, I have brown hair, I'm slightly balding, I have glasses, I'm this age, and I live in this place, and you live somewhere else, you have a different name, you have a different age, right? Stuff like that. So clusters of information. Classes are designed to kind of model that real world thing where we're not just one thing. I'm not just an age, or I'm not just a list of ages. You have different printers. You have different servers on your network. Each server has an IP address and a list of capabilities, and stuff like that. And so if you're creating a list of servers to process, each different server is its own object with an IP address and whether it's up and it's down, and what operating system it's running, what services, whatever. So you define an object with the class keyword instead of DEF, which defines a function. And so here we're going to make an object called circle, and it's only going to have one piece of data. I need to add something to my object, to my definition here. An object is a group of data of different types representing one complete object, and the functions, methods, it's a technical object-oriented programming term for it, that work with that data, that manipulate that data. What if I added spacing? All right. not perfect English, but good enough. Okay. So that's the keyword for defining an object. Now in other languages, watch this and then dump it because it's not true in this language. You define your variables like this. We're going to delete this instantly. Well, that's not how they're defined in Python. Python's kind of a weird beast. I don't know if it's because object-oriented programming was tacked onto it later after it was invented. The variables are created inside the init method that I mentioned previously. Now, methods are just functions that are attached to the object. So you do create them with the def keyword. The init method has that special syntax of the double underscores. And every init method, this is also different from Java, takes an argument, a parameter. I'll go back and I'll explain that in a minute. For the Java and C++ guys, this is the same as this reference. And so, my circle has one piece of information. It's got a radius. What this is saying is that my object tracks one piece of information. It could track 100 pieces of information if it needed to, right? If it was a complex thing. You can be pretty sure that Amazon, does object-oriented programming to track all their inventory. And so, you have a book and an ISBN number and a number of pages and a list of authors and, how many of them are on stock and stuff like that. Okay. What do we want to know about a circle? We might want to know its perimeter. We might want to know its area. Now, we could just have code down in main, right, in our main code, that uses that radius to calculate that stuff. But that's boring because we could have just created a radius down in our main code and done all that anyways. So we're going to create another function, also known as a method. I better add that as a comment. Maybe I'll do it underneath it because I don't want to clutter up what my object looked like. Get underscore area. And again, I have to pass in that self-reference. Like I said, I'm going to kind of ignore that for now. What is the area? The area of it is pi r squared. Believe that to be true. So the return value is equal to pi, and if I'd imported math, I could use math.pi, but I'm going to cheat and just call it 3.14159. 3.14159 times r squared, radius squared, self.radius to the power of 2. Now for our main code to be able to use that area, we're going to return it. Common programming mistake for object-oriented programming is to say, oh, well, that's going to be another variable. I'm going to create another variable called area, and the circle is going to track its own area. Why is that a mistake? Because that's a calculated value. I'll mention that in a minute, but you shouldn't have your object keeping track of its calculated values. It should keep track of its core values. Let's define something called get perimeter. Get perimeter. I guess that's also the same thing as circumference, right? Get circumference. Self colon. And the circumference is 2 pi r. So 2 times 3.14159 times self.radius. And then we're going to return r. And this is the end of the class. Or I could say end of circle class. That's just a comment. You don't have to have it. That's our circle object. I'm going to go under here and create some objects, but I'm going to make them mention that the def defines a method, which is a function that is part of the class. So what's the difference between a class and an object? The class is the blueprint for it. You're going to go and build yourself a fancy house. You go and pick a blueprint for your house. Your neighbor may have the same blueprint, right? And then but you hire one team to go and build your house, and then somebody else or the same team builds their house. You have two houses made from the same blueprint. The houses are the objects, the blueprint is the class. May as well add that as a keyword. The class is the blueprint. Object is the thing made from the blueprint. Right, you have technical specs for a computer, but that doesn't mean that all the computer is just the same one computer, right? We can both buy Lenovo laptops or whatever, you know, we each have our own Lenovo laptop even though they all share the same spec sheet. Spec sheet would be the class, and the laptops that we buy would be the objects. Alright, let's use our circle class. One thing to note here is that it's recommended programming, it's recommended convention, it's not a law, nobody's going to come and shoot you, that classes have an uppercase name. That's to differentiate them from the methods of functions which have a lowercase name. So I'm just going to put that down here as a comment. Make your class names start with an initial cap. Or uppercase, right? Example, circle, not circle. And we've seen that, right? Turtle. We imported the turtle library, but then when we actually started using the turtle, we had to have that uppercase T, and if we didn't, it was a syntax error. And that's true of every programming language I've seen, not just this one. All right, I'm going to make a circle. Circle C1 equals new circle. Circle C2 is equal to another new circle. Oh man, I slipped into Java. Excuse me, delete all that. C1 equals circle.
That was a little...
Yeah, C2 is equal to a circle. You can kind of tell from my typing there, even for those of y'all who haven't used other languages, that Python's got a cleaner, a shorter syntax for a lot of stuff. But at the price of a couple of little quirks, but that's okay. Every language has its quirks. All right, every circle has a radius. So C1.radius is equal to 10. C2.radius is equal to 2. Different size circles. Now let's get their areas and their circumference. Area 1 equals C1 dot get area, parentheses in parentheses. And then area 2 is equal to C2 dot get area, parentheses in parentheses. And we can print those out. Print. We're going to make this fancy. Circle C1 radius equals %F area equals %F, end quote, followed by the % sign, and then inside parentheses we have to list the things in that are going to fill in the placeholders. I'm going to skip down to the next line, which you absolutely don't have to do because your font is smaller. So C1 dot radius, comma, C1 dot, wait, and then just area 1. I'm not totally happy with my syntax here. I'm going to go ahead and make this C1 dot get area right there. Even though I summoned the area, calculated the area like this, I kind of like just demonstrating this, right? That these pieces of information are both associated with that. Now just copy that line, paste it, and change all the C1s to C2s. And let's run it. Hope I don't have any more syntax errors.
Does the get area have to be like the?
It has to be like the method, and I slipped into the Java convention of naming them. You're absolutely right. What did my function name look like? It had an underscore and a lowercase a. I'm going to scroll down here and I'm going to make that change. As I said before, that's why some companies pay to have two people sitting at the same screen. There we go. Now it ought to run. Okay, I need to get comment out that turtle code. And I had more than one place, two places where I was calling get area. I got a lot of things to fix. Get underscore area, get underscore area. There we go. Oh, for Pete's sake. Two placeholders. Two placeholders. Interesting. While I'm at it, I'm going to go and comment out my circle code. I don't want to see it draw a circle every time, so I'm going to put 3 quotes at the top. Nope, nope, not the circle, the turtle. I'm going to go way up here to my turtle information, comment out the turtle. I don't want to see it draw that picture every time anymore.
On your print statements, how you get C1.getArea, shouldn't that just be area 1?
It could be.
Don't
And since I'm getting an error, I'm going to try to simplify it by changing that to area 1. See if that fixes it. And the next one should be area 2. It was correct the way it was, except for the fact that it's not correct. So, not digging the fact that it's not correct. Just delete my entire thing? Yeah, I did. Alrighty. Area 1, area 2. What is going on? Somehow I'm hitting the delete key when I don't mean to. Alrighty. Area 2, area 1, maybe. Not enough arguments for format string. Well, that's a lie, and I'm about to punt on that because I'm not getting it. We have these arguments. Oh, I see what I'm doing wrong.
You didn't have the string.
I don't have the extra parentheses around it. Whenever you're using formatted printing, if you have more than one argument, you have to enclose your arguments in parentheses. Now I could have left it the way it was. It was correct the way it was, but all right. Please work. All right. And so circle 1's radius is 10, its area is 314. I believe that to be correct in my head. 2, that area is that. All right, just because I wanted it to work the way it did, I'm going to change that area 1 back to C1.getArea. It's not necessary. And change the area 2 back to C2.getArea. So why did I want to do it that way? One is I wanted to show you just the syntax for retrieving the variables, retrieving the data. But the other is that I wanted you to see that both pieces of information are actually part of that object. I could have written a function where we passed that object to it, and it would already have both of those pieces of information. Which is what we're going to do. By the way, since I've made 10,000 edits to it, has anybody got it broken? That's what I figured.
Changing it back.
I changed it back to C1.getArea. That was not necessary. Just Just got to make sure you have 3 close parentheses. Also, a lot of folks have get area 1 and get area 2. And that's just because I kept waffling between calling the function and using the variables. So make sure they are both called get area, because if you scroll back up, that's what the method name is inside the circle class. Alrighty, the last thing I saw is just a matter of alignment. Easy to make it your code look like that, right? That's wrong because it's defining functions inside of functions, because these functions are now inside that function, which weirdly enough is legal syntax, but it's not correct. So I would have to take those out. Should have just hit undo a couple of times. Alright, so now what do I want to do? I want to write a function that prints out information about it. The only reason I'm going to write a function that prints something about it when we're already printing information about it is that I want to demonstrate that one function can accept both turtles. So def print underscore circle. Oh, by the way, this syntax has to be exact up here. Absolutely 2 underscores on either side, no more, no less. And so if you accidentally made it 3 or something like that, that would be a problem.
You didn't unindent the get area.
Oddly enough, that doesn't matter. Yeah, the point was is I didn't unindent this stuff. That would work. As long as the indentation is consistent, right? Inside each function, the indentation has to be consistent. But why not make it look pretty, just like it was before? All right. So back down here, print circle, but it's going to take that's too much typing. Let's just call it C. And let's get all 3 pieces of information now. And this time I really am not going to embed all of that stuff inside the print statement. That made it kind of, the syntax a little bit harder to read. I wanted to have both examples. A for area is equal to C dot get underscore area, parentheses in parentheses. R is equal to C dot get underscore area, parentheses in parentheses. And now the circumference is not going to work.
Do you mean for R to be just C dot radius?
Yeah, that should have been dot radius. Thank you. C1 dot. I wanted to get this example perfect. Thank you for catching that.
Yeah.
And then since I already used C, I'm going to rename this. Sorry, guys. Circ, or I could use the letter P for perimeter. And then circ dot get area and circ dot get radius. And then I'm going to store the circumference for that object for the purposes of this function as C, and then call circ dot get circumf. I believe I tacked on an F there. Now I can print something out about it, but I'm going to make it look more normal. Print circle area, comma, end quote, comma A, print quote circle, and we could use some judicious cut and pasting to accomplish this. Radius, end quote, comma R, and then print parentheses quote circle circumference, end quote, comma C. I'm hearing a weird sound like rain.
Sounds like a mouse.
All right. Now I'm going to call that function. Print underscore circle, and I'm going to pass the C1 object to it. Print underscore circle, and the C2 object to it. We are moving around clusters of data. Awesome, thank you. We are moving around clusters of data stored as a single object name, right? Instead of having to pass the area and the radius and the circumference around 3 bits of data into that function, we can just pass 1, which is the object that contains that information. And it worked. Maybe I should have passed in the name of the circle as well, or we could have given the circle a name to store in the object or something so that we could differentiate them nicely. But we can see that it's working. Now what would be awesome? What would be awesome possum is if we could do this. Print C1, print C2, and then have that object magically turn itself into a string that contained all that information. That doesn't work though. If we just print the object, we just get that. We get the name of the class, we get the file name, or underscore main, whatever, and then some kind of hashed memory address. So that's not working. We can make that work. Let's give a silly example of making that work, as soon as I'm convinced that there's no syntax errors. We all good? What we got going on here?
I had parentheses here.
Yeah,
so we're supposed to-
okay. All right, so I'm going to scroll up here, back to the circle class, way up here, and I'm going to make a function that would convert or replace that gobbledygook with something actually useful. So make sure your DEF is lined up with the other DEFs in your circle class. Make sure you use 2 underscores on each side of what I'm about to tell you. And then parentheses self, in parentheses colon. And then just, for now, return, I am a circle. Return quote, I am a circle, end quote. Really, we'd print out more information there. We'd print out this dot radius, we'd print out the area, we'd print out the circumference, or whatever data we wanted to know about it. Oh heck, why not? I am a circle of, end quote, plus, and we need to convert that radius to a string. This language does not support that automatic conversion. We haven't been doing this too much because we separate all of our print parameters with commas, but we could be separating them with strings as long as we converted the numbers. I mean, we could be, anyways. Right, instead of commas, you could be using plus signs in your print statements, but you would have to convert all your numbers to strings, just like we're doing here. This dot radius, parentheses in parentheses. Excuse me, it's not this. We called ourselves self, so it should be self dot radius. Now, this is not a magic name. If I was a Java programmer, I'd be real tempted to don't do that. I'd be real tempted to put this there and this there, or I could call it Fred. Fred. If I'm feeling patriotic, I could call it Trump, right? But this is standard practice. That should be the name of the reference for the current object. Myself, right? All right, so now when I run it, those 2 print statements are not going to print that gobbledygook. They're actually going to print, I am a circle of, that maybe plus, quote, radius. Hope that works. Put that all in one line on yours. I'm not sure that's going to be a syntax error or not. I might have to put a backslash there to get it to continue on the same line. Boom. It did not like that. If you were going to break it into 2 lines like I did, the backslash means, okay, hey, go to the next line. But since you're smart and going to put it all in one line, you don't need to add the backslash. All right. And see, didn't print out gobbledygook. It said I'm a circle of 10 and I'm a circle of 2. So what this method does is it converts the data inside the object into a representation, a string representation, so we could print out that object in one fell swoop. Just print C1, print C2. We could add another one, which does an equals. We could compare the two circles to see if they are the same. Now, what makes them the same? I guess if they have the same radius, right? Return true if they are the same radius, else return false. Just for completeness sake, we might as well add that as well. And I'm making the circle class a little bit too complicated at this point, so we're going to make another class that's kind of a cleaner example. I mean, this is all good stuff to add. Whoops. It deleted my class again. What is wrong with my keyboard? Alright, anyways. DEF underscore underscore EQ underscore underscore parentheses self in parentheses colon. But we have to take another parameter. Why? We are comparing two circles. So, we're going to call the other circle other. So after self, put comma other. If self.radius equals other.radius, return true. That should be on 2 lines. Else colon return false. And you guys who are up, guys and girls who are up on your Boolean, realize that you could just stick the word return here and skip the next 3 lines and it would work just as well. Why is that? Because this expression returns a true or false, so we could have just returned it. I'm going to add that as a parenthetical. Could just have put return self.radius equals other.radius. If you don't feel like adding that comment, you don't have to. I won't say guys and girls anymore. I'll say gentlemen and gentlewomen. Or I'll just say guys and we all assume that it's, you know, or all y'all. That's what I'll say. All right. So I can scroll back down as soon as I'm comfortable that everybody is done typing and check to see if those two circles are the same or not. Now they're not, right? Because one has a radius of 2 and one has a radius of 10. So I'm expecting this to say no, they are not the same. Anybody need me to stay on this page a little bit longer? Okay. I'm going to compile it just to make sure that I don't have syntax errors yet, because it's very possible I do. If you do, now would be a good time for me to come back and help. All right. All right, one point I need to make is why are there no parentheses on that one? And why are there parentheses on this one? That's because that's a variable, and we never put parentheses after a variable. And these are functions, methods. And if we go back to our circle class, we will see that that's true. Radius was defined as a variable, no parentheses, and these other things were defined as functions, as methods with parentheses. Now, you might kind of want them to be consistent. We could have added a method called getRadius. Just like we have getArea and getCircumference, all it would need to do is return self.radius. And then we could be putting parentheses after everything. And that's actually better programming practice. I was just trying to make the class as simple as possible. So I'm not going to make that change this time. But let's go ahead and check to see if those circles are the same. If C1 equals C2, colon, print, quote, circles are identical, end quote, in parentheses. Else, colon, print parentheses, quote, circles are different. Now, did we have to do it that way? We could have just done if C1.radius equals C2.radius, right? But that's because we're only tracking one piece of data. What if we were tracking a cube? We'd have to check the x, y, and z of it, right, to see if they're equal or not. So that's why adding an EQ method to compare them is not a bad idea if you think you're going to be comparing them. If you're not comparing the two things, then you wouldn't even need that. Yeah, I've bragged about it a lot. Let's actually run and see what it says. It should say they're different because they have different radiuses. Or is that radii? I don't know. All right, the circles are in fact different. As an experiment, we could scroll back up and make them the same radius. If you feel like it, where we set the radius of 2, change that to a 10 and run it again, and it will say the circles are identical. I think I'll do that. Scroll back up. C2's radius is now 10. So I made a change to that line. Run it again, and if we play our cards right, the circles are identical simply because they have the same radius. All right, we're going to do another object, another class. I don't think we're going to make it this complicated because I don't think we have as much time to spend on it, but I'm not going to have to talk as much about it. Let's write a class that tracks the information about a perfect pyramid where we've got a base, like a square, and then we've got a height. So we're going to be tracking two pieces of information. So class pyramid with a capital P, colon. We're going to make this one a little bit funkier, and the reason why is because, don't put this yet, I want to be able to create my pyramid like this. P is equal to pyramid parentheses with a base of 10 and a height of 20, right? When I create my object, I want to be able to pass that information in rather than have to do this. P dot base equals 10 and P dot height equals 20 or something like that. I want to avoid doing that by setting that information when we create it. So our init function has to accept those parameters. So def underscore underscore init underscore underscore parentheses self as always, comma, base, comma, height, in parentheses colon. And now we're going to do this dot base equals base. And this dot height equal height. But we're not going to put this, we're going to put self. Self.base equals base. Self.height equals height. And that's enough. I'm going to have to Google how to get the volume of a pyramid. So I'm going to quickly swift over here. Volume of pyramid. Ta-da, it's that. Length, width, height over 3. Now in this case, the length and the width are going to be the same, so it's just going to be base times height divided by 3. How about the surface area of a pyramid? Oh boy. How about we don't implement that? All right.
That might take some interesting.
That's going to be your test question, so you don't want to take the test. I kid. Let's. All righty.
Yeah, that's done.
Okay, so we're going to get the volume of it. Def get underscore volume, parentheses self, in parentheses colon. Return this dot base star 2
Supposed to be self.
self.base, teaching Java too much, **2 times self.height.
And that was whole divided by 3, right?
Divided by 3. Now remember when I said doing that dot radius thing without the parentheses was, kind of counterintuitive. You kind of like, just for consistency's sake, being able to use methods everywhere. Define get underscore base is just going to return self.base. So define get underscore base self colon return self.base. And add one for self.height as well. Return get underscore height. DEF get underscore height, parentheses self, in parentheses colon, return self.height. Now really, it's considered better programming practice if we take all these classes and push them up to the top of the file, rather than interweaving them with our main code. It'd also be a good programming practice to stick everything inside of a main method, right? And then call that main method rather than have all of our main code strewn, weaving through all of our class definitions. Okay, I want to make a pyramid. P1 equals pyramid, and it's going to be exactly as tall as it is wide. All right, out of curiosity, what's the height of the Great Pyramid and the base of the Great Pyramid? .455. Base of Great Pyramid. Ah, come on. Width of Great Base? All right, 755. 455 and 755. Let's see if I can remember those long enough. We're going to make another pyramid. P2 equals pyramid. The base is 755 and the height is 455. There's one Egyptian pyramid where they tried to make it at a sharper angle, but then halfway through they realized it was structurally untenable, and so it goes up like that and then it goes like that. So if you made your pyramid where those values were the same, if it was big enough, it would not be stable. All right. Are we going to add an str method to it so that we could print this stuff out? Nah. But let's print our information out about it. Print parentheses, quote, P1, height equals, comma, quote, P1 dot get underscore height, parentheses in parentheses, and one more in parentheses. And then we're going to print the base and the area of it as well. Then we're going to copy all that and print out P2 height and base. It'd have been nicer, since we're copying and pasting, just to make a function that did all this like we did for the circle. Print, quote, P1 base equals, end quote, comma, P1.get base. P1.get base, parentheses in parentheses in parentheses. And then print, parentheses, quote, height base area. P1 space area equals, end quote, P1 dot get underscore area, parentheses, in parentheses, in parentheses. Then copy that and change all the P1s to P2s. Time for some judicious copying and pasting. It would be nice to either make this a function right, that we just pass a pyramid to, or if we made this the string function, the str function inside the pyramid class as well. But we didn't. Like I said, I was trying to make this one look a little bit cleaner.
Is this supposed to be get volume and area?
Yes, it is. Change area to volume in all these places because we decided not to implement area. Four places to change it. And there's our pyramids, right? Base height has a volume of 333. Now the Great Pyramid of Giza has a volume of however many feet that is. 1, 2, 3, 4, 5, 6. That's incredible, 86 million feet. That pyramid's made out of 86 million feet of stone, of cubic feet of stone. All right. That demonstrates the concept pretty well. One thing I want you to notice is that in the past, every time we had a parameter, we had to fill it in. Right? Here, we're not filling it in with anything. It fills it in itself because it has to have some way of tracking, right, what the object is. So automatically, whenever you call a method of an object, the first parameter gets filled in with the address of that object, the reference to that object. Hope that makes a little bit more sense. In these things, you can define local variables. Remember on the other one where I did, don't do this, r is equal to, and I had all that? I mean, you could do it if you wanted to. And return r, that's totally fine, but that's not a variable you can access. I could not go down here and say p1.r equals anything. I could if I did this, right? Undo all those changes. Something that people like to do, and it's incorrect, is to say this dot volume is equal to that. Don't make this change. Return this dot volume. The reason that is incorrect is because if you had the thing tracking its volume, then later if you change its height, the volume is no longer accurate. It's stale data. It's incorrect. Volume is something that should always be calculated. You don't want anything in here that could become stale. So if you change the base of it, if you did p1.base equals 20, then all of a sudden the volume would be incorrect. So that's why we did not have this dot volume as a member of the class. And I guess I should make that as a little bitty note, what the term member means. Base and height are members of the class, meaning they are part of the class. They are variables. You can also have member functions, get height, get base, and get volume, but those are more commonly called methods, so I'm not going to tack that on. So I'm going to rewrite my definition of a class. A class is a blueprint for an object with member data and methods, parentheses, functions that use that data. That's a pretty short definition. The books may reword it. My definition is better than theirs. No, I'm kidding. This is just, I teach the same one so that no matter which class I'm teaching, I think that's the clearest way of stating it, rather than using too much computerese in it. All right, so what's our homework going to be based on this? I'm just going to have you implement a different class, right? We have 2 examples, so this example is not going to be much more difficult. The reason for that is because I want you all to be working on your projects. There's been real good work on it. I've seen a couple of completed projects already. One's pretty cool. It's a Pokemon game where you pick that you're going to play Charizard, and the computer picks that he's going to play, Chimchar or something like that. And then you pick their attack, your attack, and the computer picks their attack. That was pretty cool. So Homework. Create a class that tracks the information for a block, which has a height, width, and depth. Or you could just call it H, W, and D if you feel like typing short variables. I guess they call it length out on Google. I'd rather use the whole words. All right. I want you to add some methods for get area, get the surface area, and you can just Google the formulas if you get stuck. As always, you can text me for the formulas and I'll write them down and send them to you. And get volume. Now, the volume is really super easy. It's just height times width times length. I'd like to see, but not mandatory, an STR method, and an EQ method. Your class must have an underscore init method for it to be a class. That's not my requirement. It's just a requirement. All right. Your code should create at least 2 blocks and use that data, right, to print out stuff. So we have 2 examples. I'm hoping this is not super duper duper difficult. I'm sure that on Tuesday we'll do another class, another one a little bit more complicated. Then we'll probably start doing user interface. Who took fundamentals and they did demonstrate classes? Cool. Who taught y'all?
With Waters.
Okay, cool. Good job. Good job, Professor. All righty. I think that's enough. I didn't check to see if anybody had syntax errors at the very end of it, so I'll check as soon as I create the drop boxes.